This lesson comes from Chapter 9, Section 4 in my student's textbook, and it's titled Factoring to Solve Quadratic Equations. In my class, we just got done doing factoring, so that's why I jumped into this topic. But we actually haven't even talked about what quadratic equations are yet in my class. But I wanted to start here since we were just working on factoring. So for this topic, we're going to use what's called the zero product property. And it just simply says that if you multiply two things together, like A and B, and that product is zero, then you know at least one of these has to be zero. Either the A is zero, the B is zero, or they're both zero. Okay, so that's the zero product property. And that's what we're going to be using to solve these quadratic equations. And again, if you don't know what a quadratic equation is, don't really worry about it at this point. For my students, we're going to go back to that next and learn that. So as an example, if you had x plus 3 times x plus 2 equals 0, then that would mean either x plus 3 is equal to 0 or x plus 2 is equal to 0. Okay, so one of those is equal to 0. So here's an example of the type of problem you would see in this topic. What are the solutions of the equation 4t plus 1 times t minus 2 equals 0? Now, obviously, to use this zero product property, we need this to be equal to 0. So this doesn't work if this isn't 0 over here. So we're simply going to set 4t plus 1 equal to 0, or t minus 2 equal to 0, and we're going to solve those to see what are the two values that t could be. So on this left one, this is just a two-step equation. We always do the adding or subtracting first. So I'm going to subtract 1 from both sides. So I get 4t equals -1. Divide both sides by 4. Again, you're using opposite operations to solve for the variable. And so I get that t is equal to -1/4. So if I was to plug in -1/4 in here, 4 times -1/4 plus 1 would be equal to 0. Or my other answer, most of you, I'm sure, can figure out this answer without showing any work. That's fine. For this one, I'll show my work. On the future problems we're going to do, I'm not going to show any work here. But if I add 2 to both sides, those will cancel out. And what I'm left with is t equals 2. So there's two solutions to this. T could be either -1/4, that would make this first binomial 0, or if t was 2, that would make the second binomial equal to 0. All right, so let's look at another problem like this. All right, so this one's basically the same setup. So either 2x plus 3 equals 0, or x minus 4 is equal to 0. So the zero product property says one of these has to be equal to 0 for the product to be equal to 0, at least one of them. So on this one, again, just a basic two-step equation. So I'm going to subtract 3 from both sides. So that gives me 2x equals -3. I'm going to divide both sides by 2. I'm going through this kind of quickly. If you need to, remember, you can just back it up and watch a problem again if I went too fast. So there's one of my solutions, x equals -3/2. Or my other solution, x minus 4 equals 0, that would mean that x would be equal to 4. So either one of those values of x will make this product equal to 0. All right, let's look at problem number 3. So this one's a little bit different because it hasn't been factored yet. So the first thing we're going to do with this is factor it. This is just a basic trinomial. So you're looking for two numbers whose product is 15. and whose sum is positive 8. So the product's 15 and the sum is positive 8. All right, so I'm thinking positive 5 and positive 3, right? So that would be x plus 5 times x plus 3 equals 0. If you haven't learned how to factor a trinomial, then I have another video you can go back and look at factoring trinomials. But if you're at this stage, then I would imagine you've probably already learned this. So x plus 5 has to be equal to 0 or x plus 3. So our solution is x equals negative 5 or x equals negative 3. That was a terrible box. All right, let's look at problem 4. All right, so problem 4 hasn't been factored either. This one, there's a coefficient on the a squared here. So the method that I teach my students for factoring this is commonly called slip and slide. And so the way this works is you slip the coefficient of the squared term to the end and you multiply it here. So what you end up with is a squared minus 15a plus 36 equals 0. Now at this point, you've got a basic trinomial, just like on the last problem. So you're looking for two numbers whose product is positive 36 and whose sum is negative 15. So to have a positive product and a negative sum, the only way that can happen is if the two numbers are both negative, because a negative times a negative is a positive, and a negative plus a negative is a negative. So you just want to start going through the factors of 36 and try to come up with a pair that if you add them together, it'll make 15. And so in this case, it's going to be negative 12 and negative 3. So this is going to factor to a minus 12 times a minus 3 equals 0. The order of these doesn't matter, so you could have the a minus 3 first, but you can't have 12 minus a. That doesn't work. It has to be in this order, because you should be able to FOIL this and get back to the original trinomial. All right, so now the other part of slide here is this 2 that I moved to the end. I got to bring that back. And so what we do is we divide each of these terms by that 2. And so you want to simplify 12 over 2. So it's going to simplify to a minus 6. If you have a fraction that can't be simplified, what you do, here's the slide part, you slide this denominator up next to the variable. If you're not familiar with this slip and slide technique, you might want to look into that a little more, because you're probably confused by what I'm doing. So then I get 2a minus 3 equals 0. So one of my solutions is a equals 6, right? For this one, I need to do a little bit of work. I've got 2a minus 3 equals 0, two-step equation, so add 3 to both sides. So that gives me 2a equals 3. Divide both sides by 2. And so a equals 3 halves. And so that would be your solutions to this quadratic. A equals 6 or a equals 3 halves. Either one of those answers, if you substitute it in, this equation will be equal to 0. All right, let's look at another one. All right, so this one is not equal to 0. And again, this method only works if this is equal to 0. So what we're going to do is get this equal to 0. And the way we're going to that is by adding 49 to both sides of the equation. So there's where my 0 comes from. And then I have x squared plus 14x plus 49 equals 0. All right, and now it's just a basic trinomial. So I'm looking for two numbers whose product is 49 and whose sum is 14. So it's a fairly simple one. It's just 7 and 7, right? So I have x plus 7 times x plus 7 equals 0. And hopefully you can see this one only has one solution. So both of these, if you set them equal to 0, would come out to -7. So the solution to this problem is x equals -7, and there's only one solution. All right, so I got one more for you. Here's problem 6. Again, this isn't equal to 0, so the first thing I'm going to do is set it equal to 0 by subtracting 18 from both sides. So there's my 0. On the left side, I have 4x squared minus 21x minus 18. So this one is one I'm going to have to use my slip and slide technique because there's a coefficient on the x squared. I'm going to slip this 4 down to the end. So I'm going to end up with x squared minus 21 minus 72 equals 0. And so now I'm looking for two numbers whose product is -72 and whose sum is -21. So I know one of the numbers has to be positive and one has to be negative in order for the product to be negative. And since the sum is negative, I know the larger of the two values has to be negative. So this one's a little tricky. If you get stuck trying to figure out the correct factors, what I would recommend is if you just Google factors of 72, it'll give you all of the factors and just look for a combination that you can use to get -21 when you add them together. All right, in this case, it's going to be -24 and +3. So I have x minus 24 times x plus 3. Again, the reason I know that this is negative and this is positive is for the sum to be negative, the bigger factor had to be negative. And they have to have different signs in order for the product to be negative. All right, so that gets me to there. And then this 4 that we slipped to the end, now we have to bring it back. So we have to divide here by 4. So the 24 divided by 4 will simplify to 6. The 3/4 I can't simplify, so again, what here is we slide the 4 up in front of the variable x. So this becomes 4x plus 3 equals 0. So my first solution is x equals 6. For this one, I need to do a little bit of work. So I'm going to set 4x plus 3 equal to 0 and solve this. So -3 minus 3. So 4x equals -3. I'll run out of room. There we go. Divide both sides by 4. And so x equals -3/4 is the other solution. So my solution is x equals 6 or x equals -3/4. All right, so I hope this video was helpful to you. If so, please like and subscribe. And until next time.